With the DB helper at our disposal, we can start implementing our ToDoDao and, most importantly, implement the option of adding new tasks. To do so, in the constructor, we have to create an instance of DB helper inside our ToDoDao. Because our DB helper needs a context, we also have to pass context to the ToDoDao. This way, any method called on ToDoDao will have access to the DB helper and, consequently, to the database. We'll begin with the implementation of the method responsible for inserting data. In our case, it will be the insert or update method. Our assumption is that if any new data appears, we always want to overwrite it. It's a solution to the issue of conflicts, which may arise the moment our database modification is different from the modification present in the server. In such case, the data incoming from the server will overwrite the data currently present on the device. The method we create will take ToDo as a parameter. Because we have access to the DB helper, we can get the database. There are two basic methods here: getWritable and getReadable. The difference between them is closely related to the queries we want to execute in the database. If we want to execute only read queries, we use getReadable, where we can execute all kinds of selects. If we want to modify the database in any way, we use getWritable. In our case, we'll need the second method because we'll insert entirely new elements to the database. The returned object is the SQLite database, the name we received when calling onCreate. That's why we can call various queries on it. In terms of queries, we have the relevant methods that generate SQL. We don't have to create a complete query manually. We have methods at our disposal to which we simply pass the parts of the queries which vary. We have the query responsible for select, the methods update, delete, and insert. We have three insert methods. The difference between them results from the way insert behaves the moment the query doesn't succeed. In the case of the standard insert method, either the number of the inserted lines is returned, or, if we haven't managed to insert anything, it's -1. The second possibility is calling the insert or throw method. Depending on the success or failure of the query execution, the method executes itself or throws an SQL exception, which includes an error message. The last option is the insert with onConflict method. If we try to insert the same data, this method will react accordingly. Depending on what we pass as the last parameter, the method will cancel the execution, interrupt the operation, or ignore the error. We'll be mostly interested in the third method, which in case of a conflict will react the way we choose. We have a number of parameters which we have to pass. The first one is the table name. In our case, it's a constant. The second one is null column hack. It's just a string which has to be inserted into the column in case we try to insert a null. This is because a null is treated in a special way in Java. It doesn't have to be inserted into a column. We can leave the empty value instead, or insert a null string. In our case, it will simply be a null. Another key parameter is content values. This is a map which allows mapping the column name to the value which has to be inserted there. If we look into a standard insert query, it consists of insert into name, table, column, and value. In order to carry out the mapping of columns to values, we need content values. To do so, we create a values object, which we'll fill in a moment. The last parameter is the way our method should react the moment it detects a conflict. There are a number of possibilities defined as constants. We can, for instance, interrupt the entire transaction, ignore the error, we can do nothing, or possibly substitute something. Even though we try to insert identical data, we inform the query that we're aware of that, and the action has to be carried out. This method will be of particular interest to us. We just need the column, value mapping. We carry out the mapping by creating a values object and inserting the right values into it. Given that there are several values, we can make a shortcut and copy the mapping from the file along with the example. The mapping is pretty straightforward. We have the name of the column where we insert a specific value. In case of basic values, there are no problems. There is the so-called content column into which we insert our content. We have the done field where we insert a Boolean flag which, when saving, is converted by SQLite into the number 0 or 1. Next, we have the columns created at and updated at. In our model, these are dates. In Java, dates are stored below as a long which includes a timestamp from the beginning of 1970. Calling getTime returns us such a long. All the data is written to the database, thanks to which we'll be able to easily read it. The last thing we need to do is to save the user ID and place everything inside our insert. The query constructed this way will physically insert the object into the database by creating an insert and calling it.